Eighth graders. So in this lesson, we're going to take what we took from the first lesson where we were solving equations with square roots or using square roots. And we're now going to basically real world it. Where is another place where we use square roots to solve equations? And one of those most often used in your math classes is called the Pythagorean Theorem. And so we're going to get started on that. Maybe if I click right. There we go. So Pythagorean theorem is used with the parts of a right triangle or with right triangles to find side lengths. That's the purpose of the Pythagorean theorem. So we need to know the parts of the right triangle. One thing you need to know is that the hypotenuse is always across. Opposite. It's the side opposite of the right angle. And so this is our right angle. And if you don't remember what a right angle is, a right angle is an angle that measures 90 degrees, and we indicate that in mathematics or geometry with a square because squares have right angles. The hypotenuse is also always the longest side. So we'll always have the biggest side length. And so that's what you need to know. Again, the hypotenuse is always across from the right angle, and it is the longest side. The other two sides we call legs. The legs hold up the hypotenuse, just like legs hold us up. So, moving on. This is the wordy version of the Pythagorean theorem. If a triangle is a right triangle, then the sum of the squares of the lengths of the legs, so we're calling A and B our legs right now, is equal to the square of the length of the hypotenuse. So let's break this down. Sum, we should know that sum means that we're adding of the squares of the lengths of the legs. So we're going to call one of the legs A, and squares means we're squaring it. Got A squared and B squared is equal to the square of the length of the hypotenuse. So here's my hypotenuse, hypo, and so c squared. You have probably heard this before, a squared plus b squared equals c squared, or seen some memes making fun of math and whatnot and talking about the Pythagorean theorem. But where is this used in real life? A lot of times it is used in carpentry to make sure that what they're about to cut is a square or a right triangle, because if you know that your sides follow this, a squared plus b squared equals c squared, then you know you have a right triangle. So that's one way that it's used, and actually that's how it came about, was when they were trying to do quite a bit of building and knowing whether or not they had right triangles. So a lot of the trades use Pythagorean theorem. C, we say C is always the hypotenuse because C is normally listed in the place of the hypotenuse, but I would always still go from your right angle and draw an arrow and say, ah, that's my hypotenuse, just FYI. In the equation, that is always your hypotenuse. When it comes to a squared plus b squared equals c squared. All right, so what is the length of the hypotenuse of this triangle? So here's my right angle, so I'm going to go across, so that's going to be my C. It doesn't matter what you call these, A or B, because we're adding them, and addition can happen in any order. So we're doing a squared plus b squared equals c squared. So I'm going to do 3 squared plus 4 squared equals c squared. And then so 3 squared, 3 times 3 is 9. And 4 squared, 4 times 4 is 16. Or you use a calculator and you type with the little square, not times 2, right? But there's that little x squared button that you can use. And then we're going to add them together. So 9 plus 16 is 25. Now this is where we get with what we were working with before. And I have c squared and I need to get c by itself. So my last step is that I'm going to square root. And the square root of 25, well, 5 times 5 is 25. So our answer is 5. C equals 5. Now, in the last lesson we talked about plus or minus, but we're working with triangles, and you can't have a negative side length. It's impossible. So it's just positive. Our answer for this is just positive. All right, so let's do our next example. What is the length of the hypotenuse of the triangle? So again, I always double check. There's my right angle. So here's my hypotenuse. I just tend to label them this way. You could change your label as whatever you want. You could do 5 for A and 12 for B. It's okay. All right, so A squared plus B squared equals C squared. I said that A was 12, so I'm going to substitute that in. And B was 5, so I'm going to substitute that in. So now I have 12 squared plus 5 squared equals C squared. 12 squared, 12 times 12 is 144. 5 squared is 25. Right? And then we're going to take 144 plus 25, and we end up with 169 equals C squared. Now remember, I'm looking for the length of C, not C squared, and so in order to get C by itself, we're going to take the square root. And so now we have C, so C equals, and the square root of 169 is 13, because remember 13 squared makes us giggle. And so that's what we're doing. That's Pythagorean Theorem. It's just plug and chug, and at the end we take the square root. Square, square, add, take the square root. All right, so we have a couple more examples. Maybe like, oh my goodness, I think I have it, but you never know. Someone else may be like, I still have no idea what's going on, Mrs. Cartwright. All right, so I'm going to call this A and this one B. I'm going to do A squared plus B squared equals C squared. So 7 squared plus 24 squared equals C squared. Again, I could flip those if I wanted. 7 times 7 is 49. 24 times 24, which it is okay to do it in the calculator, or 24 squared is 576 equals C squared. And then we're going to add these together. So 49 plus 576 gives us 625. And if you're wondering how Mrs. Cartwright's doing that so quickly, I give myself a little script before I do these. So it's already worked out. And then I'm going to do the square root because I've got to make this just a C and not a C squared. And what I do to one side, I have to do to the other. And so then we're going to type into the calculator. I'll show you this one. I'll show you this one just because a lot of them have been on our list and we haven't had to use the square root. So I'm going to click square root and then 625. And so our answer is 25. And so that's what we will put. C equals 25. All right, I want you to know it is okay to use a calculator for these. Please, please use a calculator. Last one, I believe. Let me double check. Oh, I lied. There's one more after this. A baseball diamond is a square with 90-foot side lengths. So 90 feet is our side lengths. To the nearest tenth, what is the distance from home plate to second base? And so that makes a right triangle, right? Because it's a square, and our angles on a square are all right. So I am looking for, there's my right triangle, or right angle, and I'm looking for C. So I know I have 90 squared plus 90 squared, because that's my A and my B, right? And A squared plus B squared equals C squared. All right, so from here, 90 squared is 1,800, so I have two of those. And then I'm going to add those together, and I end up with 16,200. I really need to start using commas when I write my notes. And then from here, I'm going to take the square root because that's our last thing because we got to get c by itself. So we're going to take the square root of both sides. And what we end up with is a decimal. And let me see what else. When I did the square root of 16,200, I end up with 127.27, and I'm going to round to the nearest tenth because that's what it says in the problem. And so I'm wanting, this is the one I'm rounding to, so I'm going to look at the one behind it, the 7, and 5 or above, give it a shove. So 7 is above 5, so we're going to change the 7 to a 3. And so we end up with 127 point, and the 7 changes the 2 to a 3. 127.3 feet. That is our answer. All right. So we're doing the same thing. We just got to keep track of what decimal it wants us to change to. All right, so here is our last example. We are working with the Great Pyramid to the nearest hundredth. So that's 2 decimals. What is the slant height of the Great Pyramid? So we haven't talked about pyramids, but a slant height is actually the height of the side triangle based off of your right triangle on the inside. So this length here, this bottom, because we're working with square pyramids, it is always going to be half of the side length. So if we were to take 230.35 and divide by 2, we're going to get 115.175. So that's how we're getting that side length. We're going to call that one A. And then this one they're giving to us, we're going to call that one B. And so A squared plus B squared. And we're looking for our C. They're calling it L because that's what we label slant height. We're going to go ahead and call this for now C squared. So we're going to type in 115.175 squared plus 146.71 squared. I'm going to go ahead and change it to that little cursive L because that's what they gave us here. And when I square these, I end up with the following numbers, 2, 6, 5. Now, I'm going to write quite a few decimals, and I highly suggest that if you can keep your decimals in your calculator, that's how you're going to get the most exact answer. The more you round, the least exact, or the more off your answer becomes. All right, so I got those 2 numbers. Now I'm going to add them together, and that becomes 34,789.10473. That's L squared. Now to get the slant height by itself, we're going to square root both sides. And when I type that into the calculator, I end up getting 186.52 meters. And so that's my slant height. And again, I typed that number, 34,789.10473. I typed the whole thing in. We wanted to the nearest hundredth. I would have looked at the 3rd decimal to determine whether I changed the 2. I don't remember if it was a 1 or if it was a 2. So just remember 5 or above, give it a shove, 4 below, let it lie low. But that's how Pythagorean theorem works. A squared plus B squared equals C squared. We square our 2 terms, add them together, take the square root. That's basically what we're doing. Until next time, 8th graders, peace out.